You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Chivalry, or the chivalric code, is an informal and varying code of conduct developed in Europe between 1170 and 1220. It's a combination of qualities expected of an ideal knight: courage, honor, courtesy, justice, and a readiness to help the weak, stepping in to take the heat for someone else, the brave standing up for the meek. It's alive and kicking in the space industry, with SpaceX stepping in with the FAA to be jointly sued, though put aside your pre-Raphaelite notions of romantic honor. The motivation in this case is purely business.
T-minus 20 seconds to LOS egress. Go for deploy.
Today is May 23rd, 2023. I'm Maria Varmazis, and this is T-minus. No, sue me, says SpaceX. Virgin Orbit's assets to be divided between 3 space companies. The OneWeb satellite network portal is a step closer to reality. News from GeoInt, L3 Harris to look for human movement in a haystack. And my conversation with Steve Tomaszewski, Senior Director at the Aerospace Industries Association on National Security Space Considerations and Policy. Stay with us. Now let's take a look at your intel briefing for today. Yeah, you might have heard that a number of environmental groups are suing the Federal Aviation Administration over SpaceX's Starship launch, saying that not enough was done to lessen the impact to nearby wildlife and environmentally sensitive areas around Starbase in Boca Chica, Texas. Now, the FAA licenses launches like Starships. You might remember the when launch frenzy in March and April, as it seemed everything was in order for Starship. Everything that is except the FAA launch permit. So if environmental groups are successful in suing the FAA, you could imagine that any future Starship launches would not only be subject to additional scrutiny, but also lots more delays. We're talking on the scale of years, potentially. And that, of course, would have a detrimental ripple effect on any business or endeavor that's depending on Starship launches, for example, like Starlink. And that's exactly what SpaceX is worried about, too. So they've filed a motion to intervene, essentially to join the lawsuit as a co-defendant along with the FAA. The FAA does not adequately represent SpaceX's interests, says SpaceX's motion to join the lawsuit. Essentially, it's like they're saying to the plaintiffs, don't talk about me like I'm not here. So you could argue that SpaceX's move here is a bit chivalric. Don't bring all the heat on the FAA when it's me you really want. But it's also a little bit of taxi driver, isn't it? You talking to me? And on to an update on Virgin Orbit's status now. And 3 aerospace companies are due to benefit from the sales of the launch company's assets. Rocket Lab, Stratolaunch, and Vast Space have all been named in court filings that divide Virgin Orbit's belongings as part of the bankruptcy proceedings that started back in April. Rocket Lab bid $16.1 million for Virgin's Long Beach headquarters and production equipment. Stratolaunch will purchase Virgin Orbit's 747 carrier aircraft called Cosmic Girl for $17 million, along with other aircraft assets. And Launcher, a subsidiary of Vast Space, is due to purchase the company's facilities at Mojave Air and Spaceport for a mere $2.7 million. Sales are due to be approved by the bankruptcy court in the next 24 hours, and we will keep you posted. Moving on, and we've got a lot of satellite news for you today. So let's start with Arctic Space Technology and OneWeb, who have finalized the design and obtained all approvals for the construction of the OneWeb Satellite Network Portal, or SNP, which is a hyperscale satellite ground station installation at the Arctic Space Technologies Space Center in Sweden. The company signed an agreement in December 2022 to install 27 satellite tracking antenna systems at the site, which they plan to have operational later this year. The new site will provide increased connectivity for OneWeb customers across industries, including maritime and aviation. And OneWeb has also announced successful communication with 16 satellites deployed on a Falcon 9 rideshare, which brings their total to 634 satellites on orbit. The satellites were successfully launched from Vandenberg Air Force Base on May 20th, alongside 5 Iridium satellites, bringing the total of Iridium spare satellites in orbit to 14. 81 next-generation Iridium satellites have been built, and 80 of them have now been deployed, which completes their upgraded constellation. The Iridium constellation features 66 operational cross-linked satellites. The company has been leading the satellite direct-to-device movement, partnering with Qualcomm Technologies to enable satellite SOS and two-way messaging in premium Android smartphones. Viasat is progressing with its acquisition of Inmarsat, as we reported yesterday, saying that it has received the Federal Communications Commission's approval for the purchase. In an update, the company said the approval leaves only the European Commission's competition review in the way of its acquisition effort. Meanwhile, in an update, Inmarsat has selected Freewave as a partner for a global Internet of Things solutions provider. Freewave Technologies has agreed to be a distribution partner for Inmarsat's L-band satellite IoT services. The partnership will focus on the integration of Inmarsat's iSat Data Pro service in Freewave's end-to-end IoT solutions. It's hoped that the agreement will provide Freewave's customers with connectivity solutions across industries including agriculture, oil and gas, and utilities, and will also support the use of IoT in businesses operating in the environmental tracking space, including earthquake and flooding monitoring firms. And some news coming out of GeoInt in St. Louis. And I apologize, yesterday I said St. Louis. Can't take the Massachusetts out of the girl, I guess. And L3Harris Technologies have announced new contracts for space-based communications and data analysis. The first contract is with the U.S. Air Force Research Lab for up to $80 million to test satellite communication systems designed to operate with space-based internet constellations operating in geostationary, medium, and low Earth orbits. L3Harris has also been awarded an Intelligence Advanced Research Project Activity, also known as IARPA, contract to study human mobility based on data obtained by satellites, GPS, Bluetooth, and other sources. The IARPA contract is part of the Hidden Activity Signal and Trajectory Anomaly Characterization, known as HASTAC program. This study will simulate human activity in various locations and cultures with the aim to predict movement during disaster relief efforts. Talk about looking for a human movement in a haystack. Anyway, we'll just move on from that one. And the Air Force Research Laboratory has awarded Ursa Major a contract to advance U.S. hypersonics defense programs and space launch capabilities. The contract allows Ursa Major to build a prototype of its hypersonic Draper engine, as well as to further develop its 20,000-pound thrust Arrowway reusable liquid oxygen and methane staged combustion engine for medium and heavy launch vehicles. Ursa Major says their Draper engine will become the foundation of America's counter-hypersonic capabilities, and it is applicable for both space access and hypersonic applications. The rocket manufacturing company says the Draper engine aligns with AFRL's efforts in enhancing technical capabilities to deliver assets rapidly and effectively to high-energy orbits or military-relevant orbits. And T-Minus would like to extend our heartfelt congratulations to the Spaceport Company for holding the first demonstration of its offshore platform this week. The floating spaceport prototype hosted 4 sounding rocket demonstrations by Evolution Space and successfully demonstrated its proof of concept. The rockets were the first ever commercial launches from U.S. territorial waters. Now, I got to speak with Spaceport Company CEO and founder Tom Murata on May 1st, so make sure you listen to that conversation at space.n2k.com if you missed it. And finally, some investment reports we thought might be of interest to you. Market Research Future has released a report on the space mining market, which it has estimated to be worth $1.99 billion by 2027. You can read the full report, along with other articles we think you might like, in the selected reading section on our website, which is, again, space.n2k.com. And that's our Intel briefing for today's show. Coming up next is my chat with Steve Tomaszewski, who's the Senior Director at the Aerospace Industries Association. And hey, T-Minus crew, our audience is growing rapidly, and that is a big thanks to you. If you're just joining us, welcome, and be sure to follow T-Minus Space Daily in your favorite podcast app. And also, do us a favor if you could, please share your favorite episodes on social media. It helps professionals like you find the show and join the crew. You can find our social media profiles in the show notes and, as always, at space.n2k.com.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
In today's interview, we're getting into the changes and challenges in the use of space in the national security space. My guest has a unique vantage point to speak on the importance of resilient space architectures, as well as opportunities and hurdles that the space industry might encounter there. And we'll be discussing the growing threats and exciting developments that are shaping the future of national security space. Here's our conversation. Steve, thank you so much for joining me today. We were chatting a little bit before the interview, and you sort of described yourself as the national security space guy, which is such a great title. So in that vein, let's dive into it a bit. Give me a sort of a lay of the land in terms of national security space, if you could.
Absolutely. So we are in the middle of a revolution in national security space. This is because our military and intelligence community use space for more and more of their missions. And also our adversaries have noticed what we're doing in space, and they're building robust threat systems to challenge us in the space domain. So this increases our military's dependence on space for almost all missions that it does. At the same time, our adversaries recognize that if they want to have an asymmetric advantage, if they ever had to go toe-to-toe with the United States or our allies, they could target space systems compared to going direct combat with us in the maritime or air domains or land domains. So we see a lot of interest from our potential adversaries building up a suite of counter-space threat systems that can challenge us, and that's really challenging the establishment of what we've been doing with national security space and forcing us to think differently.
Yeah, so what kind of technological innovations are we seeing that are maybe changing the landscape for the warfighter?
First and foremost, communications. There are no fiber lines going to aircraft carriers in the middle of the ocean. So the Navy is incredibly dependent on satellite communications for pretty much everything that it does. Also, missile warning and battle space awareness. We have dedicated satellite constellations in space that are tuned to look at big hot flashes coming from things like intercontinental ballistic missiles and giving us that early warning to either shoot down incoming missiles or just be aware of where they're potentially going. We also use space for positioning, navigation, and timing. So the Global Positioning System constellation that everyone should be familiar with is actually owned and operated by the United States Space Force. We also depend on space for weather and keeping track of all the changing weather patterns to support current operations. We do intelligence and surveillance and reconnaissance from space. And lastly, space domain awareness. You might also hear this called space situational awareness. It's using a network of ground-based and also space-based sensors to keep track of all the different objects and satellites that are out in space.
How do we make sure that all those expensive, hard to get up into orbit assets are being secured and stay resilient as they're up there?
And you really hit on it. It's all about resiliency. So this is something that you're going to hear a lot about with national security space. And it's making sure that our constellations are resilient against threats. And that actually comes in a number of different layers. So first of all, for the satellites themselves, you want them to be able to be defendable, make sure they can protect themselves if they can, and not be vulnerable to certain types of counter space threat systems that could potentially attack them. You also want to do things like proliferate your architectures, have a number of satellites doing redundant things. So if one gets taken out, there's going to be backup systems, and you don't have single points of failure. Something else that is part of resiliency is what they call reconstitution. If there is some sort of a satellite taking out or a capability that's disrupted, you want to have the ability to come back in and replenish or reconstitute that critical capability and do that in an operational manner. So there's a lot of elements of that, and there's not a single solution for resiliency across the board. It has to be an all of the above type of approach.
And something I like to frame when I'm thinking about something as broad as national security space are challenges and opportunities. So what do you see in terms of challenges in the next, say, 5 years? And then on the flip side, what are some great opportunities there?
For challenges, I might start out by saying, these threats to satellites are really robust, and they are increasing, and we have to take them very seriously. The response to those threats is maybe where the opportunities come in. So there's been a lot of reorganization across national security space. Just in the last couple of years, we've seen new organizations stand up, like the United States Space Force as the newest military branch. We've also seen the reestablishment of United States Space Command. That is, back as one of the combatant commands. And we also see a number of different space acquisition organizations that are now coming to the table and providing capabilities, such as the Space Development Agency, the Space Rapid Capabilities Office. So there's a lot of opportunities to do this right and to kind of change the way that we've approached space in the past. But there are a number of challenges, making sure that we have budget stability for our national security space capabilities. Every time we go to a continuing resolution, from the Congress for appropriating funds, that is a challenge. So we want to try to have continued budget support for everything that we're doing in national security space. And making sure that all of these new organizations are working well together and collaborating is also going to be a challenge. The last challenge I might highlight for you, but also an opportunity, is collaboration with industry. With all of the great new things happening in the commercial space sector, it's really challenging our national security space actors to try to take advantage of all the great things that are happening out there and to respond and integrate those capabilities in a deliberate and responsive manner. There's a lot of opportunities out there, but the challenge is doing that effectively and making sure that those capabilities are getting brought online so they can actually be used by the warfighter and our national policymakers.
If we were speaking directly to industry right now, it sounds like one of the directives there is about responsiveness and timing. Anything else that industry should know about specifically working in security space, national security space, rather?
Yeah, and I might flip the question just a little bit of talking about what does industry want. So as a trade association at the Aerospace Industries Association, we have the privilege of representing over 320 companies across the aerospace and defense industry. And there's a number of things that these companies can agree on, in particular to national security space. So we talked a little bit about kind of budget stability and making sure that the federal government is consistently funded. We talked a little bit about building building resilient architectures and finding all of the above ways to actually protect and defend our national security space architectures. The other piece that's really important right now is strengthening our supply chain and having resilience in the supply chain. So space is a domain that has very specialized materials, specialized technologies, and very technical workforce challenges. And making sure that we not only have those science, technology, engineering, and math graduates to tackle some of the hardest engineering problems, but also for the skilled technical workforce. Think about things like folks that might not have a college degree, but your welders, your machinists, your coders. That's incredibly important for the space industry and national security space. And there's competition kind of across the board for those very specialized workers. And the last thing I might throw out here, and this is something that industry struggles with, but also it's something that even parts of our U.S. government struggles with is overclassification. And what I mean by that is traditionally there are a number of space programs that have been incredibly classified. And we've done that for very important reasons, making sure that we can retain our competitive edge against our competitors. But sometimes that actually restricts what we can actually share, whether that's sharing information with international allies and partners, whether it's collaborating with different parts of industry who might have really interesting ideas to solve some of these hard challenges. So that also has to be addressed, making sure that we can protect our information appropriately, but also finding opportunities for collaboration and transparency.
Are we specifically talking about ITAR in this case, or is there something else that you have in mind?
It's more than just ITAR. It's even how the U.S. government shares information amongst itself between different organizations. There's challenges there. There's challenges between the Department of Defense and the intelligence community, sharing across those two parts there, and then helping and collaborating directly with industry as well, finding ways that industry can bid on new programs as an example, but making sure that they have the right tickets for different classified programs to have the opportunities even to kind of think through some of those things. So it's an all of the above, and then with international allies and partners, even operationally sharing information can be a big challenge.
One last question for you. What are you really excited about when you look ahead in terms of what's coming? What are some really cool things that are maybe heading our way that you're like, this might change things, or this might really improve things for national security space?
The biggest thing I'm excited about is all of the support for national security space across the board. Putting this in context with making sure that different parts of the national security space enterprise are properly funded from the federal government, we are seeing a resurgence and a lot of money getting added to the budget for things like the Space Force right now. So let me put that in context for you. In the fiscal year 2024 President's budget request that recently came out, NASA had a budget request of a little over $27 billion, which is a lot of money. But let's compare that to the Space Force. In the Space Force's fiscal year 2024 budget request, it was a little over $30 billion, so more than the NASA budget request. And where that's gone, even in the last couple of years, if we go back to fiscal year 2021, the Space Force's budget request was $15 billion, so about half of that. Now, there's a little bit of nuance there, as a lot of programs have been transferring into the Space Force, so not all of that is organic growth, but we do see big areas, especially when we're talking about satellite communications, missile warning and tracking, that are taking advantage of some of these new resilient architectures and seeing a lot of money going towards those mission areas. But the other piece that you don't see in that Space Force budget request is how other military services like the Army, Navy, and Marine Corps are utilizing space, because they are purchasing their own things like GPS receivers and satellite communications dishes separately, and it's not included in how the Space Force is providing capabilities. It also doesn't include some of the space-based intelligence, surveillance, and reconnaissance assets and constellations that the military is using there. So that's the biggest thing I'm excited about. Is national security space is really getting a lot of attention, and it's folks are realizing the benefits from space, and they're dependent on them more and more. And as long as we can meet that challenge challenge with finding ways to continue to make resilient architectures and protect our assets and provide some redundancy in case those assets are targeted, that's really how we're going to win in space.
Steve, I can't think of a better wrap-up than that. Thank you so much for joining me today.
Thank you so much.
And we'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCorps Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. Now, when we talk about events that affect radio wave propagation and satellites, usually those events are coming from the sun. Bursts of electromagnetic interference from sun activity, coronal mass ejections, things like that. But sometimes things here on terra firma are the cause of similar problems. Even though it's rare, but it does happen. But those events have got to be big. Really big. Like massive volcanic explosion big. Like the Hunga Tonga Hunga Ha'apai submarine volcano that exploded last January near the Kingdom of Tonga in the South Pacific. It made for some astounding photos, if you remember them. The plume reached 35 miles into the air and was the most powerful natural explosion on Earth for more than a century. And it made some incredible waves in the water. There were tsunami warnings galore from that explosion. And it made waves in the atmosphere, too. In fact, scientists at the Institute for Space Earth Environmental Research at Japan's Nagoya University have announced their discovery that the volcano's explosion last year caused a disturbance in air pressure so great that it affected the ionosphere, all the way up to the F layer of the ionosphere, to be exact, about 620 miles above the Earth. And that was high up enough to cause disruptions in satellite communications. And it's amazing to think that a volcano could affect a satellite. Now, radio enthusiasts know that the F layer of the ionosphere is the kind of giant reflector dish you can bounce radio signals off of. The electron-dense F layer is what hams around the world often use to bounce high-frequency signals to one another. And Hunga Tonga Hunga Ha'apai's explosion last year created plasma bubbles forced up into the bottom side of the F layer, basically bubbling up as it went. Kind of like a gassy kid in a bathtub. You're welcome for that visual. And that's it for T-Minus for May 23rd, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. See you tomorrow.